Third and final differentiation technique for year 13 differentiation is the quotient rule. So the quotient rule is a differential method that applies when you have the quotient of two functions, quotient being the division. So the product rule was when you had u times v, and the quotient is when you have u divided by v. Now, one thing to point out is that with the product rule, it doesn't matter which you call u and v, because u times v equals v times u. However, with the quotient rule, it does matter. U is the numerator and v is the denominator, and it matters which way around they are, because u divided by v is not the same as v divided by u. Okay, so just be careful with that in this definition. So what I'm going to do is I'm going to use two different methods to derive the quotient rule formula. You don't need to know either of the derivations. I just like to give you where they come from. So the first way I'm going to show you where it comes from is I'm going to use the product rule on this. So I'm going to say that y is actually u times v to the minus 1, and I'm going to apply the product rule. So the product rule says that dy by dx is going to be this times the differential of that plus that times the differential of this. So it's easy to do that times the differential of this. So it's going to be v to the minus 1 times du by dx. And then we need to do this times the differential of that, which is a little bit trickier because you need to do u times the differential of v to the minus 1, but you need to differentiate it with respect to x. So what I'm going to do is I'm going to use the chain rule on this bit, and I'm not going to differentiate it with respect to x at all. I'm going to differentiate it with respect to v, and then I'm going to times it by dv by dx. So it's going to be u times d by dv times v to the minus 1. Of v to the minus 1 times dv by dx. Okay, now this is the chain rule, and I know I've not done the implicit differentiation video yet. It comes later on in the series. This is actually implicit differentiation. We're implicitly differentiating a function of v with respect to x, and this is how we deal with it. We say, nope, I'm going to differentiate it with respect to the variable that's in, and then I'll times it by this correction term. And it's essentially an application of the chain rule. Okay, so this I'm going to keep as it is for a minute. Du by dx. Differential of that. I'm now differentiating v to the minus 1 with respect to v, so that is minus v to the minus 2, okay, times by the power, subtract 1 from the power, and that's going to be times dv by dx, which I'm now going to write as u primed divided by v minus u v primed divided by v squared. Okay, so I'm just shorthanding my notation now. So du by dx is u primed, the v to the minus 1 is over v, the u is on top, the v primed is on top, and we have the v squared on the bottom, and the negative there has carried through to there. Okay, that's two different fractions. I'm just going to put it over the same fraction, but times in this one top and bottom by v. So that gives me that dy by dx is u primed v minus u v primed, all divided by v squared. Okay, and that is the quotient rule. So if you like, give it in its full form, dy by dx is going to equal v times du by dx minus u times dv by dx, all divided by v squared. And that is the quotient rule formula. That's the bit you need to learn, and that's the bit we need to use in questions. Okay, the second method of deriving this formula is similar to the way that I derived the product rule formula. So I'm going to say that y plus delta y is going to be u plus delta u divided by v plus delta v. Okay, so I've essentially taken y equals u over v, and I'm adding a little bit in the x direction, and adding a little bit in the x direction has a knock-on effect, and adds a little bit in the u direction to u, adds a little bit in the v direction to v, and adds a little bit in the y direction to y. This isn't quite as nice as the product rule one was, because I can just multiply out the brackets, but this one I can't. I can't just take the terms because I've got two additions, one addition on the bottom. So what I'm actually going to do is I'm going to use the binomial expansion on this bit. So v plus delta v to the minus 1, that's the same as v to the minus 1 into 1 plus delta v over v to the minus 1. Now I can use the binomial expansion Okay, if not sure what I'm doing here, check out my binomial expansion videos for year 13. So 1 plus nx, so that's minus dv over v, plus n times n minus 1, so that's minus 1 times minus 2, divided by 2 factorial, so that just becomes positive 1 times that squared, so that's going to be delta v over v all squared, and then I'm going to get delta v over v all cubed, and then plus, and so on. It just keeps increasing in power. But delta v is going to be really small because I'm going to take it to be 0 a bit later, so I don't actually care about all of these terms over here because they're going to be negligible. So I'm actually just going to say that this bracket is the same as this times the first two terms. Okay. So that's going to give me that y plus delta y is the same as u plus delta u multiplied by v to the minus 1 into 1 minus delta v on v. Okay. Now I'll multiply out that bracket. I'm going to get u times v to the minus 1, so that's u divided by v, plus delta u divided by v, minus u delta v divided by v squared, because I've got that times that, and then I've also got the delta u delta v term there, so that's delta u delta v over v squared, and there'd be more terms which I'm ignoring, but that's what y plus delta y equals. And now we can see how the y cancels with that one, because y is u on v, so I get delta y is this thing, and as I did with the product rule, I'm now going to divide it by delta x, so that's going to be delta u divided by delta x divided by v, minus u times delta v over delta x divided by v squared, minus delta u times delta v over delta x divided by v squared. And now taking delta x to be 0, that term there will disappear, and this term, this will go to dy dx, this will go to du by dx, and this will go to dv by dx, and then put them over the same fraction, and we will get that dy by dx is equal to v times du by dx minus u times dv by dx, all divided by v squared. Okay, exactly the same as I had derived up here in the first method. You don't need to know either of those derivations, but there's just two different ways that you can see how this is indeed the quotient rule. And what's nice about this one is in the Edexcel spec for A-level, it is given in the formula book, so you can just use it. Okay, don't need to remember this one. Okay, right, on to some examples then. Example number 1. Y equals x squared plus 1 over x cubed minus 1. So we're going to set the top to be u, and the top of the fraction is always u. U primed is 2x. V is always the bottom of the fraction, and v primed in this case will be 3x squared. And now it's not quite the sum product as we had before, because the formula is v u primed minus u v primed divided by v squared. Okay, so that is what I'm going to be plugging these into. So just be careful that you are plugging in to the correct formula in the correct places. So therefore dy by dx is going to equal vu primed, so that's that times that, so that's going to be 2x to the 4 minus 2x minus uv primed, so it's minus that times that, so it's minus 3x to the 4 minus 3x squared, and that's all divided by v squared, which is x cubed minus 1 all squared. And you can simplify the top a little bit in this case. 2x to the 4 minus 3x to the 4 is going to give me minus x to the 4, and then I've got my minus 3x squared and my minus 2x as well. Leave the bottom factorised, it just looks a bit nicer than trying to multiply it all out. That's it. Example number 2. Not looked at tan yet, and that's because we need the quotient rule to do it. So now that we have the quotient rule, we can differentiate. So we're going to have u is sine of x, which means u primed is the cosine of x, v is the cosine of x, and v primed is the negative sine of x. Okay, and that's because tan is sine over cos. Again, the formula for the differential is vu primed minus uv primed over v squared. So plugging these four into this definition, we're going to get dy by dx is equal to cos squared, okay, vu primed, minus uv primed, but minus and minus is plus, so that's actually plus sine squared of x, all divided by v squared, which is cos squared of x. But the top is the number 1, because cos squared of x plus sine squared of x is always 1. So that is identical to sec squared of x. There we go. So the differential of tan is sec squared. Good one to remember. Example 3. U is the log of x, which means u primed is 1 over x. V is e to the x, which means v primed is also e to the x. And we're going to have vu primed minus uv primed, all divided by v squared. Plug those into the formula. We're going to end up with dy by dx is equal to e to the x over x minus e to the x log x, all divided by v squared, which is e to the 2x. Okay, in this case, we can cancel the e's a little bit, and that's because it differentiates to itself, so that's quite nice. And the x I'm going to bring to the bottom of the fraction as well. So I'm going to get 1 minus x log x divided by x e to the x. And there's your derivative. Okay, so I times each term on the top by x and times the bottom term by x. Okay, which is why the x disappeared there, but it's appeared there and there. And the e has cancelled from those with one of the e's from the bottom. So it's left me with just an e to the x on the bottom. Example 4. U being the top of the fraction, sine, I'm going to say is x squared plus x. U primed, we're going to need to use a little bit of a chain rule here. Once you get really good with the chain rule, you can just write the answer down. You don't have to actually go over here to do w stuff. So that's cos of x squared plus x. Okay, the sine differentiates to the cos. The contents of the trig stays the same, but I need to times by the differential of what's inside, which is 2x plus 1. And v is the bottom, so that's x plus 1, and v primed is 1. Okay, so don't forget the formula, which is vu primed minus uv primed all over v squared. We're going to take these four and plug them into that definition, and that's going to give me that dy by dx. In this case, is x plus 1 times 2x plus 1 times the cosine of x squared plus x minus that times that, so it's minus sine of x squared plus x, and that is all divided by v squared, which is x plus 1 squared. Okay, just leave it like that. Okay.